Hey guys, Doc Sig here to talk about covalent bonding and octet rule. So what is covalent bonding? It's bonding that occurs when pairs of electrons are shared by atoms. Only valence electrons are involved, and the purpose is to gain stability. And how that's done is through octet rule. Octet rule requires atoms to be surrounded by 8 valence electrons. This is either done by sharing, losing, or gaining electrons to become more stable. This pertains largely to elements with 2s and 2p subshells, and we'll detail that in a future video. I always tell my students, remember 8 is great. Everyone wants octet, and they want that noble gas configuration. So let's look at Lewis structures that are represented by covalent bonds, starting with single bonds. H2 diatomic, so I have 2 times 1. The 1 is for the 1 valence that hydrogen has, will give me 2 total to work with. So I drew one of the hydrogens in pink and the other in blue so you can see them pairing together like puzzle pieces, and the dots in between them I can later represent with a line or a dash. HCl, so I have 1 hydrogen times 1 valence plus 1 chlorine times the 7 gives me 8. Again, the hydrogen's in pink, and I'll show its 1 valence electron configuration, and the chlorine has 7. And in between them, those 2 dots, I'll represent that with a dash to show that connectivity. Now look at chlorine, it has 3 lone pairs. You have to keep those, you have to represent them. Don't make them disappear. Now chlorine feels like it has 8. There's 2 in the bond, and then there's 6 surrounding. So 8 is great confirmation. Octet rule achieved. Now going back to the previous example, you can't do that with hydrogens. It's just too small, it can't achieve that. What about fluorine? 2 times 7 valence electrons for the fluorine gives me 14. I'll show 1 fluorine in pink, the other in blue, and the 2 dots that come in between the atoms I'll represent with a dash. And you can see again, I have lone pairs I have to represent around each of the fluorines. Don't get rid of them. So each fluorine feels like it has achieved the octet rule because you have 2, 4, 6, 8 around the one, and the same goes for the other. What about methane, CH4? 1 times 4 plus 4 times 1 gives me 8. Carbon will be my central atom represented in pink. I'll put the hydrogens in blue so you can see their contribution to the Lewis structure. Now I'm going to represent that with the dash formation. And there you go. And carbon, 2, 4, 6, 8 around those bonds feels like it has 8 octet rule achieved. Let's look at double bonds. CO2. 1 times 4 for the carbon. 2 times 6 for the oxygen gives me 16. So I'll draw the oxygens in blue, the carbon in pink, and you can see that when I represent this, I have 2 sets of dots in between the oxygen and the carbon on either side. I'll represent those with double bonds. So carbon's going to feel like it has achieved octet, 2, 4, 6, 8. Oxygen's going to feel like it achieved octet, 2, 4, 6, 8 on both of them. And so that's a high stability. So now let's look at C2H4, ethene. Carbon has 2 times 4 plus 1 times 4 gives me 12. I'll represent the carbons in pink, and I'm going to start by putting the hydrogens around them. And then the last 2 sets of valence, I'm going to swing in between the carbons. And because carbon wants to have 4 attachments, right? And so because I have those 2 dots, I'll represent that with 2 double bonds. So each carbon has 2, 4, 6, 8, octet achieved. Lastly, triple bonds. So diatomic N2, 2 times 5 valence electrons gives me 10. Nitrogen wants to make 3 connections, triple bond. So I'll put 1 nitrogen in pink and 1 in blue to show the contribution. And those 3 dots in between I can represent as 3 dashes. And swing the lone pairs on the outside of each nitrogen. And now each nitrogen feels like it has 2, 4, 6, 8, octet achieved. What about C2H2? 2 times 4 for the carbon, plus 2 times 1 for the hydrogen gives me 10. So now I'm going to represent the carbons in pink, hydrogens in blue, flanked on the outside. You can see I have the 3 sets, lone pairs in between. I'll represent that with 3 dashes. And now each carbon has 2, 4, 6, 8, octet achieved. That's it. Till next time. See you later.